Okay, chaps, so we're moving on in analytical geometry. And what we're going to do now, we're going to learn how to prove that certain quadrilaterals are parallelogram, rectangle, rhombus, and that's it. Okay? Now, what we're going to do is take our knowledge from Euclidean and apply it here in analytical. So there's still a lot of Euclidean in it, but what the good thing is, it's not that formal. You don't have to puke out all these reasoning. Okay, that's why I personally think it's much nicer than Euclidean. So we've got a quadrilateral, right? It has four sides, and we want to prove that it's a parallelogram, and we got all the coordinates. Okay, so first of all, let's hear from you. What do you think we can do? Okay, so guys here and the ladies, figure out 3 out of 4. Okay, so there's 4 ways of doing it. One is to find the distance of this side, find the distance of that side, show they're equal. Do that the same for these 2 sides. So you have to calculate the 4 sides and show that each pair has equal distance, not distance, length. Okay. The other option, okay, find the gradient of this, find the gradient of that, show that they're equal. That's where you're proving that they're parallel. Okay. Find the gradient of that, showing that they're equal to the gradient of that. Again, you're showing that both pairs are parallel to each other. Then the third option, you just take one pair, let's say these 2, and you calculate the distance, you show the same, and you calculate the gradient, you show the same. So you just need one pair. All of these are more difficult than the fourth option. The fourth option is to show that the diagonals bisect each other. Okay? Show the diagonal bisect. If you look again in Euclidean, you will see that another way of showing that, proving the parallelogram is the parallelogram is just show that the diagonals dissect. That only happens in the parallel. Okay? So how are we going to prove the parallel dissect each other? Any ideas here? Right, so the answer is midpoint. You're right. What we're going to show, we're going to find what's the midpoint between these 2 points. Okay? We're going to find it. And then we show the midpoint, find the midpoint between these 2 points. And if the midpoints are the same, that means they bisect each other. So the middle of that is in the same point as the middle of that. That means that they bisect each other. So let's find the midpoint of 3, 0 and 0, 2. So we're going to call it xm. We'll find xm according to those 2. Okay? So xm according to those 2 will be 0 plus 3 divided by 2. Right? 0 plus 3 divided by 2, 1.5. And ym is going to be 2 plus 0 divided by 2, which is 1. Okay? Right, now I'm going to write, let's just do that. Now I'm going to find the midpoint according to these points. Okay, now I'm going to call it xm with a little, we call it chukchik in Hebrew. Little line, chukchik. Okay, right, because I know I want to show that it's the same, but I don't know it necessarily isn't the same. Okay, it could be that the midpoint here for these lines is here, and the midpoint here is on this line here. They might not coincide. Coincide means they're not on top of each other. So we're going to find the xm with a chukchik, okay? You know what? Yeah, okay. So that's going to be minus 2 plus 5 divided by 2, which is, again, 1.5. And ym with the chukchik is minus 3 plus 5 divided by 2. You guys can still see it, I hope. Yeah, 2 divided by 2 is still 1. And guess what? We're getting the same point, right? We get 1, 5 and 1, okay? And 1, 5 and 1. It's the same point. So the midpoint coincide. Voila, we've got midpoint. Right, we'll pause here for a little break and we'll move on up. Right, so that was parallelogram. Now we're moving to rhombus, okay? So we want to show or prove that this is a rhombus, okay? Right. Now, to prove something is a rhombus, okay, let's try and maybe, I'll ask you, how do we prove a rhombus is a rhombus? What do I need to prove? Okay. Okay, so to prove that a rhombus is a rhombus, okay, what is really a rhombus? The definition of a rhombus is that all sides are equal. Okay, so in theory, what I can do is find the distance here, distance there, distance formula, show that they're all equal. And that's going to be a long one if you think every time you have to use that distance formula. So if you proved already that it is a parallelogram, just like we did now, by just showing that the diagonals bisect, then there's a shortcut. What you can just say, either prove that one pair of adjacent sides are equal, okay, and then that means all sides are equal, or, and again it's easy, and that's what we're going to do, is show that these diagonals don't just bisect each other, they are perpendicular to each other, they're in right angle. Now how do I show that they are perpendicular? The gradients. I calculate the gradients, and if I time the gradient, it will be equal to minus 1. So let's do that. Okay, I'll give it some names. So A, B, C, D. So let's find MAD, the gradient of AD. Well, gradient, okay, is delta y over delta x. Okay? Right? Delta y, please check me guys, I'll say, but please check I do make mistake, is going to be 7 minus 0. I'll start with this side, so I must also do that side. Minus 3, minus 4. Okay? And that should be equal to minus 1 if I'm not mistaken. Okay? Now, MEB, okay, is going to be 2 minus 5, 2 minus 5 divided by minus 1 minus 2. Minus 1 minus 2. And that's equal to minus 3 divided by minus 3, which is equal to 1. And then MAD times MEB is equal to minus 1 times 1, which is minus 1. So AD is perpendicular to EB. Okay? And therefore it's a rhombus. Okay, so it is something that I told you earlier in the year. In maths, there's almost always more than one way of proving it. Okay? We could have, for example, and by the way, I'll just put it as an aside, obviously, this is true. I can go this way only if I already proved that this is a parallelogram. So the first step I should have done what I did before is show that the midpoint, okay, is coincide. The midpoint for this line is the same midpoint as that line. So we didn't do it now, but in the test you will have to do it. Only then you can show that these lines also are perpendicular to each other. But going back to what I said, we could have also calculated the distance here using the distance formula, okay, which, just show you for a second, distance formula, right? A bit tricky. So find the distance formula for this, calculate the distance for that, show that it's the same. But that's going to be more difficult and longer. So going back to what I said earlier in the year, you have to really find the cool way, like a matador. Remember we spoke about that? Bullfighting? And do it as least as possible. Cool as a cucumber. Fantastic. Right, we'll pause here. Right, so lastly, we're going to prove that we've got a rectangle here. How do we prove something is a rectangle? I asked you before the video and you answered very well. First of all, we need to show that it's a parallelogram. So how can I prove that it's a parallelogram? I need to show that the midpoint of each of these diagonals is the same point. They coincide. Okay, important word to get familiar with. Coincide. They're on top of each other. So the middle of AC is also the middle of BD. Okay?
Show that.
No, I need to show it. So we've done it. We can find the midpoint of AC. You can do that. It's not difficult. Find the midpoint of BD. You find it and you show it's the same point. Right? So now we know, I'm not doing it. You guys can do it. We've done it many times. It's not difficult. We show the midpoint is the same. So now we know it's a parallelogram. How do I know that parallelogram is actually a rectangle? It's not just a parallelogram. There's two ways. One, to show that the diagonals are not just bisect each other, they're also equal to each other. So how would I show that these two diagonals are the same distance? What would I use? What formula? The distance formula. But now, you're already starting to see, I think, the distance formula is the most difficult one, isn't it? Because it has squares and square roots. Rather use midpoint theorem or calculating gradient. Okay? So we can do that, but we don't want to do that. Instead, we want to show that the angle here, just one angle, I need to show that just one interior angle in this parallelogram is 90. And that's easy to do. You just calculate gradient, multiply, and you get minus 1. Okay? So let's prove the find the gradient of a line AD. Okay? It's going to be 9 minus 3 divided by 4 minus 5. Good one, James. Okay, 6 divided by 9, 2 over 3. Okay, now we calculate the gradient of AB. And let me just actually start from A. So 3 minus 0 minus 5 minus 3 is 3 over minus 2, I think, right? 3 over minus 2. Okay, now we're going to multiply both gradients. Open bracket is going to be minus 1, okay? 2 over 3 times minus 3 over 2, cross, minus 1. Okay? Much easier than using the distance formula. Let's stop here. Cheerio, until next time.